Perform full wave rectifier using this bridge circuit. So here is the connection for full wave bridge rectifier. Instead of selecting these two diodes, we have to select here this bridge. Okay, I think the remaining connection is going to be same like full wave rectifier, but here we have to select this bridge instead of these two diodes. So I am going to connect this bridge here. So this common terminal from this 12 volt should be connected to the this bridge, and then this 12 volt AC power supply terminal must be connected to another terminal of this bridge. Okay, then 0 volt, whatever the 0 volt is there, we should connect it to the, instead of directly connecting to the voltmeter, we have to connect to bridge and then connect to negative terminal of the voltmeter. So we have to connect all the 4 terminals of the bridge. So I have connected here 0 volt to the one terminal of the bridge, and that is connected to the voltmeter here. So then one more terminal we have to connect it to the this voltmeter. So all the 4 arms of the bridges has been connected. So only difference is, instead of using these 2 diodes, we are selecting this bridge to perform full wave rectifier. So the remaining connection here, voltmeter, DC voltmeter should be connected to these 2 terminals of the voltmeter, and the ammeter should be connected to the ammeter, these 2 terminals, positive and negative, and this is the load resistance. So let us switch on the device here, and before that, switches you should keep in proper way. So once I switch on the device, you can observe here the DC voltage is reading about nearly 11 volt, and the DC power supply, actually it is 12 volt, so near to that, and here DC voltmeter is reading 8 volt. The current is minimum. So let us switch on the device. So we can observe the deflection in the AC voltmeter. It has reached nearly 10 volt. Then the DC voltmeter is reading about 6 volt. Here the milliammeter is reading near to 125 milliampere for the 50 ohm load resistance. So let us switch, keep the switch S1 on. We can see the changes, and then press the switch S2 on. So small variation we can observe in these 3 meters. So let us vary the load resistance. Okay, so I am increasing it by 100 ohm. So current is going to increase as resistance increases. So I am here. So I am going to vary the load resistance here. So I am going to increase it by 100 ohm. So we can observe the deflections here. The voltage has been increased and the current is going to decrease. Once again I will increase the resistance. So voltage is increasing, DC voltage, and the current is decreased to 50 milliampere. So right now I have applied 330 ohm, 500 ohm, 1k ohm, and last one 10k ohm. If I will apply, current reads minimum value 0 and the voltage is reached up to 14 volt, and this is quite same near to 11 or 12 volt DC AC power supply. So this is how you can perform half wave, full wave rectifier and full wave rectifier using the bridge circuit. Calculate the ripple factor by taking the ratio of DC voltage to the AC voltage. So full wave bridge rectifier is also going to produce the same output as the full wave rectifier. This is the bridge circuit diagram, or the diode bridge rectifier we can call. If we want to perform positive half cycle, this is the circuit diagram, and if we want to perform negative half cycle, this is the circuit diagram. So you can observe here the arrow marks of the diode, the current across them. Bridge rectifier, resultant output waveform using this bridge rectifier. So this is the bridge rectifier ripple voltage given by this equation.